So, hello students, welcome to the solution of IIT JAM 2022 मैथमेटिक्स. ओके, सो 2022 का जो मैथमेटिक्स का पेपर था विथ रिस्पेक्ट टू 2021 आसान था. 2020 में बहुत सारे ऐसे क्वेश्चंस थे जो आप बहुत ही आसानी से सॉल्व कर सकते थे. ठीक है, सो स्पेशली 22 में लीनियर अलजेब्रा का क्वेश्चन बहुत आसान आया था. ठीक है, 22 में लीनियर अलजेब्रा से 23 मार्क्स के क्वेश्चन पूछे गए थे. अमंग दिस 23 मार्क्स 3 क्वेश्चन पूछा गया था 1 मार्क्स के और 10 क्वेश्चन पूछा गया था 2 मार्क्स के. ठीक है, तो अमंग दिस 3 जो 1 मार्क्स का 3 क्वेश्चन था बहुत ही आसान था और 2 मार्क्स का जो क्वेश्चन था ये भी आसान ही था. अमंग दिस 23 यू कैन गेट 20 इजीली. ठीक है, तो जो पहला क्वेश्चन, नाउ वी आर गोइंग टू सॉल्व द क्वेश्चन नंबर 1. क्वेश्चन नंबर 1 लीनियर अलजेब्रा से ही था. क्वेश्चन नंबर 1 बोल रहा है, ओके, जो पहला क्वेश्चन था, पहला क्वेश्चन बोल रहा है कि क्वेश्चन नंबर 1 says that consider a 2 cross 2 matrix. Let me erase it just a second. Okay, we have to consider a 2 cross 2 matrix M. 2 cross 2 matrix M is of the form 1 1 1 0. M is of the form 1 1 1 0. Okay, and if the 8th power of M satisfying the condition M to the power 8 into 2 cross 1 matrix 1 0 is equal to xy, we have to find out the value of x. Okay, options are, option A is 21, option B is 22, option C is 34 and option D is 35. So we have to find out the value of x. Okay, now you can solve this question in various ways. Okay, among these, first of all you can find out the value of m to the power 8 by multiplying m with n 8 times, then multiply that m to the power 8 with 1 0, this matrix, to find out the value of x. This is one of the way, but I am not going to follow that way. I am going to solve this question by finding its characteristic polynomial. Okay, now observe that the matrix M is of the form 1 0 1 1 1 0. Okay, then characteristic polynomial of M is 1 minus x 1 1 minus x, right? This is the characteristic polynomial of M, which is equal to 1 minus x into minus x minus 1. So I can write it minus x plus x square minus 1, which is equal to x square minus x minus 1. This is the characteristic polynomial of M. Now we know that any square matrix satisfies this characteristic polynomial by Cayley-Hamilton theorem. So M is a square matrix whose characteristic polynomial is this. So I can say that M satisfying this polynomial. So M square minus M minus I would be equal to 0. So from this I can say that M square is equal to M plus I. Very easy. So till now we got the value of M square, right? Now let me erase it. Okay, so we got the value of M square. Now let us find the value of M to the power 4. M to the power 4. M to the power 4 is equal to M square multiplied by M square. Now M square is equal to M plus I, and again M square is equal to M plus I, right? So multiplying M plus I with M plus I, I will get M square plus M plus M plus I. So M square plus 2M plus I. Now put the value of M square M plus I in this equation. I will get M plus I plus 2M plus I, which is equal to 3M plus 2I, right? So the value of M to the power 4 is equal to 3M plus 2I. So we got the value of M to the power 4. Now let us find out the value of M to the power 8. Okay, so M to the power 8 is equal to M to the power 4 multiplied by M to the power 4. Now M to the power 4 is equal to 3M plus 2I multiplied with 3M plus 2i, which is equal to 9m square plus 6m plus 6m again plus 4i, right? So which is equal to 9m square plus 12m plus 4i. Now put the value of m square. M square is equal to m plus I, so 9m plus 12m would be equal to 21m plus, and 9i plus 4i is equal to 13i. So this is the value of m to the power 8. So we got the value of m to the power 8 is equal to, I am removing all this, I don't need it anymore. M to the power 8 is equal to 21m plus 13i. Okay. Now I am considering this 2 cross 1 matrix 1 0 as to be our alpha. Now we have to find out the value of m to the power 8 alpha, which is equal to 21m plus 13i into alpha, which is equal to 21 m alpha plus 13 alpha. Now m is equal to 1 1 1 0 and alpha is equal to 1 0, so m alpha is equal to multiplied 1 1 with 1 1, that is equal to 1 1. So 21, the value of m alpha is equal to 1 1, so putting 1 and 1 plus 13 into alpha is equal to 1 0, so 34 by 21. So I can say that the value of x is equal to 34, right? So the value of x is equal to 34. 34 is our option C. So I can say that option C is our correct option. This is a very easy question, right? So तुम आप लोगों का मार्कशीट में 1 मार्क्स आ गया, ठीक है ना? So let's solve the question number 2. Question number 2 is again a very easy question. Question number 2 में एक 4 क्रॉस 6 मैट्रिक्स का रैंक पूछा गया है, ठीक है? Just a second. Yeah. Question number 2 में a matrix is given by, I am considering this matrix as to be A is equal to 1 1 1, then 3 zeros, 1 0 0 1 1 0, okay, 0 1 0 1 0 1, and then the fourth row is 0 0 1 0 1 1. This is a 4 cross 6 matrix, right? So we have to find out the rank of this matrix. Options are 1 2 3 and 4. These are the 4 ranks. Now to find out the rank of this matrix, I am going to use a very well-known fact of linear algebra, or a matrix of order m cross n, that is a matrix A be a matrix of order m cross n. Okay, m cross n. Then rank of A. For the time being, I am denoting this rank of A as row of A. Row of A is always less or equals to minimum of m comma n. This is a very well-known result in linear algebra, right? So this matrix A is equal to a 4 cross 6 matrix. So I can say that row of A, that is a rank of A, is less or equals to minimum of 4 comma 6, which is equal to 4. So rank of A is less or equals to 4. Now I am considering a 4 cross 4 minor from the matrix A, that is this minor. Okay, it is a very easy question. Now let me show you that. Till now we got that rank of A is less or equals to 4, right? Now let us consider this minor 1 1 1 0 1 0 0 1 0 1 0 0 0 0 1 0, right? Now I am breaking this determinant with respect to this 1, so which is equal to minus 1 into, cancelling these rows and these columns, 1 1 0 1 0 1 1 0 1 and 0 1 1, right? Now and this determinant is not equal to 0, as This is one of the bases of our R3, right? 1 1 0 1 1 0 1 0 1 0 1 1. This is one of our well-known bases of R3. So I can say that this is a non-zero minor of order 4 cross 4. So I can say that row of A is greater or equal to 4, right? So combining these two, I can say that row of A, that is rank of A, is equal to 4. It was an easy question, right? It was a very easy question. Okay. Now, so we already have discussed question number 1 and 2, and we got 2 marks, right? Now let us discuss question number 3. क्वेश्चन नंबर 3 भी बहुत आसान क्वेश्चन था. क्वेश्चन नंबर 3 में कुछ एक वेक्टर स्पेस दिया हुआ है और कुछ वेक्टर स्पेस का कुछ सबसेट दिया हुआ है और वो लोग पूछ रहा है कि कौन सा सबसेट सबस्पेस फॉर्म करेगा. ठीक है. सो जो वेक्टर स्पेस दिया हुआ है वो वेक्टर स्पेस है V is a vector space of all polynomial in one variable with real coefficient. V is the vector space of all polynomial in one variable with real coefficient of degree less or equals to 6. That is our P6. We denote this vector space as P6. P6 means vector space of all real polynomial in one variable of degree at most 6. Okay. Now इस polynomial का इस वेक्टर स्पेस का कुछ सबसेट दिया हुआ है. पहला सबसेट दिया हुआ है कि all such f belongs to V such that f of half does not belongs to Q. ये क्या सबस्पेस फॉर्म करेगा. दूसरा दिया हुआ है कि all such f belongs to V such that f of half is equal to 1. ये क्या सबस्पेस फॉर्म करेगा. all such f belongs to V such that f of half is equal to f of 1. ये क्या सबस्पेस फॉर्म करेगा. और ऑप्शन नंबर 4 दिया हुआ है all such f belongs to V such that f dash half is equal to 1. ये क्या सबस्पेस फॉर्म करेगा. तो हमें चेक करना है इनमें से कौन सा सबसेट एक सबस्पेस फॉर्म करेगा. पहले आप लोग पहले जो हमें ऑब्जर्व करना होगा P6 में मतलब वेक्टर स्पेस ऑफ ऑल पॉलिनोमियल ऑफ डिग्री एट मोस्ट 6, राइट. नाउ P6 का जो आइडेंटिटी एलिमेंट है वो क्या है. वो जीरो पॉलिनोमियल है. दैट इज अ पॉलिनोमियल fx is equal to 0. That is the identity element of P6, right? Or now just recall some results of linear algebra. Let me tell you that if V be a vector space, V be a vector space, and W be a subspace of V, right? V is a vector space and W is a subspace of V. We know that both V and W has same identity element with respect to addition, right? I am repeating my argument again. I am saying that this vector space V and its subspace W has same identity element with respect to addition, right? So identity element of V is equal to fx is equal to 0 for all x. Now, so D, if I am considering is subset as to be our W1. Now, if W1 is a subspace of V, I am without loss of I am assuming that W1 is a subspace of V. If W1 is a subspace of V, it means W1 do have that identity element fx is equal to 0. If W1 contains this identity element fx is equal to 0, then what is the value of f of half? F of half is again 0 as this polynomial is 0 at all points. So f of half is equal to 0. Now 0 is a rational number which do belongs to Q. But if this polynomial belongs to this set, then f of half is equal to 0 makes a contradiction, right? So I can say that this is not a subspace as this do not contain this identity element. Okay. By same argument, f of half is equal to 1. It do not contain that identity element, so it is again is not a subspace. Are you getting my point? This is again not a subspace. Now the fourth option, fx is equal to 0 is the polynomial. Now what is the derivative of fx? F dash x is again 0. Again, which makes a contradiction of this. So this is a recurrent option, that is also v f belongs to V, that is f of half is equal to this is a subspace of V. Now I can prove it as this contains this identity element, as we are considering this identity element. If gx is equal to 0 for all x, then g of half is equal to g of 1, which is equal to 0. So g belongs to this set. So this is a non-empty set. Now let us take two functions. I am considering this as w2, f1 comma f2 belongs to w2. Okay. if f1 f2 belongs to w2, then I can say that f1 of half is equal to f1 of 1 and f2 of half is again f2 of 1, right? This is the conditions of f1 and f2. Now then what is the f1 minus f2 of, what is the value of f1 minus f2 of half, which is equal to f1 of half minus f2 of half, which is equal to f1 of 1 minus f2 of 1. By using this fact, so I can say that this is equal to f1 minus f2 of 1. By similar argument, you can show that the scalar multiplication also do belongs to this set. So this is a subspace of V. So option C is our correct option. So ऐसा क्वेश्चन पूछा गया है इस साल के जैम में. So I think these three questions is clear to all of you. Now let's solve the next question. Next question is of 2 marks. Okay, so let's solve it. The next question which they have asked from linear algebra is question number 16. Question number 16 says that P be a M4R, means P belongs to M4R, that is P is a 4 cross 4 matrix with real entries. Okay, such that P to the power 4 is a 0 matrix. It means that P to the power 4 is a 0 matrix. Okay, and P cube is a non-zero matrix, and P cube is not equal to 0 matrix. Okay, now very good. Non-zero matrix, and which of the following option is false? So we have to find out the wrong option. First option says that for every non-zero vector V in R4, the subset V, PV, P square V, P cube V of real vector space R4 is linearly independent. Means for every V belongs to R to the power 4, V, PV, P square V, P cube V is linearly independent. Okay, this is the first option. Option B says that, or second option says that rank of P to the power K is 4 minus K, where K equal to 1, 2, 3, 4. It means rank of P to the power 4 is 4 minus 4 is 0. Rank of P cube is 4 minus 3 is equal to 1. Okay. Option C is third option says that 0 is an eigenvalue of P. 0 is an eigenvalue of P. And fourth option says that for if Q belongs to M4R, it means Q is again a 4 cross 4 matrix such that Q to the power 4 is again 0. Q to the power 4 is again 0 and Q cube is again non-zero. Okay. Then there exists a non-singular matrix S, that is S not equals to data of S not equal to 0. Non-singular matrix S such that S inverse QS is equal to P. Okay. Now let me explain the options. Third option says that if there exists a 4 cross 4 matrix Q such that Q to the power 4 is again 0 and Q cube is again non-zero, and there exists a non-singular matrix S such that S inverse Q P, S inverse QS is equal to P. It do means that P is similar to Q, right? Now we have to find out the wrong option, that is the false option. Okay, we can solve this question very easy. You can solve this question easily. First of all, observe that P to the power 4 is the 0 matrix, right? So if P to the power 4 is equal to 0, I am taking determinant both sides. As I am getting determinant, so I can write determinant of P to the power 4 is equal to 0, right? P to the power 4 is equal to 0. Now, it means that det of P the whole to the power 4 is equal to 0. We know that det of AB equal to det of A into det of B. So I can say that from this I can say that det of P is equal to 0. Okay. It means that det of P is equal to 0. If now आप लोग बात समझिए कि P मैट्रिक्स तो सिंगुलर हो गया. अगर P मैट्रिक्स सिंगुलर हो गया तो P मैट्रिक्स का रैंक क्या 4 हो सकता है? नहीं हो सकता है ना. So P matrix का rank क्या होगा? So I can say that I am row of P, that is the rank of P is less than 4. ठीक है? P matrix का rank 4 से कम होगा. Now P matrix का rank अगर 4 से कम होगा तो हम लोग बोल सकते हैं कि nullity of P, n of P is greater than equal to 1. ठीक है ना? By rank nullity theorem. Now just take a vector V from n of P. Take a vector V that is belongs to the null space of P. Okay, it means that if V belongs to null space of P, that is P into V equal to 0. Okay, now I am taking this V from null space of P. Now the dimension of null space of P is greater than 1. As dimension of null space of P is greater than 1, I can choose this V as a non-zero vector. So I am choosing a non-zero vector V from null space of P, that is P into V is equal to 0. Now observe the first option. First option says that for every V belongs to R to the power 4, and they have given that V is again a non-null vector. Okay, for every V belongs to R to the power 4 and V is a non-null vector, the vectors V, PV, P square V, P cube V is linearly independent. Now observe that we have chosen a V belongs to null space of P. Okay, now V belongs to null space of P means PV is equal to 0. So this vector becomes our theta. Okay, that is the null vector. Now if this set contains null vector, can I say that this set is linearly independent? We know that any set contains a null vector is always linearly dependent. So this is our wrong option. So this, for this question, this is our required option also. Okay, and more precisely this option is correct, as any two nilpotent matrix, P is a nilpotent matrix and Q is a nilpotent matrix of same order, so they will be a similar matrix, and as P is a nilpotent matrix, 0 is an eigenvalue of P, and this is a very well known result. So these three options correct. So first option is option 1 is false. That is our required option. Okay, so we have discussed question number 16, right? So just a second, let me remove it. Let us discuss the next question. Next question, question number 17 is again from linear algebra. Question number 17 says that xy belongs to M2R, that is xy are 2 cross 2 real matrix, that is belongs to M2R. Okay, then define, we have defined xy like this, xy minus yx. Okay, we have defined it. Okay, and 0 belongs to M2R. It means 0 is a 2 cross 2 0 matrix. Okay, so option P says, statement P says that bracket of x, bracket of yz plus bracket of y, bracket of zx plus bracket of z xy is equal to 0. This is our P, and Q is says that x y z is equal to xy z. We have to check which option is true and which one is false. That is P true, Q false, Q true, P false, both P true, P and Q true, both P and Q false. Okay, first of all, let us justify this option, second option. Okay, okay, so first says that xy is equal to bracket xy is equal to xy minus yx. So it means that x y z, it means that x yz minus zy, right? This is the meaning of it, and it means that x yz minus zy minus yz minus zy into x. Okay, now simplify it. X y z minus x z y minus y z x minus z y x. Okay, so we have simplified it. This is the left hand side. Now let us find the right hand. Let us simplify the right hand side. Okay, so simplify it. So y x y z, right? X y z. Now x y z is equal to x y minus y x z. It means that x y minus y x z minus z into x y minus y x. Now x y z minus y x z, okay, minus z x y minus z y x. Now is this equal to the left hand side? X y z x y z x z y minus x z y minus x z y. There is no x z y. Okay, y z x, there is again no y z x, z y x, z y x. So these two terms are same, and y x z, there is no y x z as well. So I can say that this false. So Q is false. Okay. Now observe that what we did, we have find that this x y z is equal to x y z, that is multiplied all terms, minus x z y, that is interchange y and z, then minus y z x minus z y x. Now I am using this fact to find out this. Okay, so this is equal to, I am using this result, x y z minus x z y minus y z x minus to be plus z y x. Okay, now y z x, that is first term is, now observe this first term is actually the multiplication of these three terms. So for this we have to multiply x with y with z, y with z with x. Okay, the second term is keeping the first term same, interchanging the second and third term, right? So we have to keep the first term same and we need to interchange the second and third term, y x z. Now let's see the third option. Third option is means we have to start from y, then z, then x, right? Y z x. So we have to start from z x y, z x y. Now let's see the fourth option. We have to start from z, then y, then x. So we have to start from x for this, x, then z, then y, right? Now similarly, the first term is the multiplication of these two terms, z, x, y. We have to keep the first term same and need to interchange that second and third term. So z, y, x, right? Now we have to start from y, then z, then x. Then that is, we have to start from x, then y, then z. Now the last is we have to from y, then x, then z. Now is it equal to 0? Now we can see this, there is a xyz plus, there is a xyz minus. So cancelling this, there is a minus xzy. Is there any xzy? Yeah, there is a xzy. Yzx, yzx, zyx, zyx. Okay, yxz, yxz, and this is equal to this, which is equal to 0. So P is true, Q is false. P is true, is Q is false is our option. Let me tell you the option. Option P is true, Q is false is option B. So I can say that option B is our required option. So this is again a question of 2 marks. It was a very easy question, right? So you.